Good morning, student. How are you? I think you are all well. And welcome to BBPS e-learning class. And we are describing over the science class. That is, the topic is going on. That is the fun with magnets. In the previous videos, you have seen that what are the natural magnet, what are the artificial magnet, and some properties of magnet, how many poles did you find in a magnet. And in this video, we have shown how to find the direction of a place by using a compass. How to finding the directions. Magnets were known to the people from ancient times. Many properties of magnet were also known to them. You might have read many interesting stories about the uses of magnet. One of such stories is about an emperor in China named Hong Tai. It is said that he had a chariot with a statue of a lady that could rotate in any direction. It had an extended arm as if it was showing the way. The statue had an interesting property. What interesting property the statue have? It would rest in such a position that its extended arm always point towards the south. And why this its extended arm always pointed towards the south? Because our earth is also behave like a magnet, and earth magnetism is known as geographical north and geographical south. And by looking at the extended arm of the statue, the emperor was able to locate direction when he went to new places on his chariot. Now we have just described about the activity 5. Take a bar magnet, put a mark on of its end for identification. We have taken a bar magnet and we put a mark on its end. Suppose this is a north pole and this is a south pole. Now tie a thread at the middle of the magnet so that you may suspend it from a wooden stand. And after that we have to tie a magnet with a thread and we are suspended it from a wooden stand, and make sure that the magnet can rotate freely. It can rotate freely. Let it come to the rest. By rotating, after that it can come to the rest. Mark 2 points on the ground. Now make 2 points on the ground to show the position of the ends of the magnet when it comes to rest. Draw the line joining the 2 points. This line shows the direction in which the magnet was pointing in its position of the rest. Now rotate the magnet by gently pushing one end in any direction and let it come into rest. Firstly, we have taken the magnet north pole. Then we have rotated the magnet to the south pole. That's why this activity says that now rotate the magnet by gently pushing one end in any direction and then repeating the activity, let it come to the rest. Again mark the position of the two ends in its position of the rest. Does the magnet now point in a different direction? Rotate the magnet in other direction and note the final direction in which it comes to rest. Do you find that magnet always comes to rest in the same direction? Yes, we always find that magnet always comes to rest in the same direction. Now can you guess the mystery behind the statue in the emperor's chariot? Repeat this activity with an iron bar and a plastic or a wooden scale instead of a magnet. Do not use light objects for this activity and avoid doing it where there are air currents are there. Do the other material also come to rest in the same direction? No. Other material not comes to rest in the same direction. we find that the result of this activity is we find that a freely suspended bar magnet always come to rest in a particular direction, which is north south direction. Use the direction of the rising sun in the morning to find out the rough direction towards the east where you are doing this experiment. If you stand the facing east, to your left will be north. Using the sun for finding direction may not be very exact, but it will help to make out the direction north from the south on your line. Using this, you can figure out which end of the magnet is pointing to the north and which points is the south. The end of the magnet, the end of the magnet that points towards north is called north seeking end or the north pole of the magnet. If magnet is showing the north pole, then earth magnet is showing to the south pole. The other end that points towards the south is called south seeking end or the south pole of the magnet. It means the earth magnetism towards the magnet, that is the north pole. All magnets have two poles, whatever their shape may be. Usually north pole and south pole are marked on the magnet. This property of magnet is very useful for us. For centuries, travelers have been making use of this property of magnet to find the direction. It is said that in olden days, travelers used to find direction by suspending natural magnet with a thread which they always carried with them. Later on, a device was developed based on these properties of magnet, and it is known as a compass. And a device which is used for developed on this property of magnet is commonly known as compass. And its compass, we have seen that it is a small box with a glass cover on it, and a magnetized needle you have seen is pivoted inside the box, which can rotate freely. The compass also has a dial with direction. Just see in the diagram. Direction, it has a dial with direction marked on it, and the compass is kept at a place where we wish to know the direction. Its needle indicates the north south direction. When it comes to rest, the compass is then rotated until the north and south mark on the dial are at the two ends of the needle. To identify north pole of the magnetic needle, it is always painted in different color. Now this is the whole structure of the compass we have discussed, and it is always used to finding the direction, and the pointer which is placed inside the compass is always pointed towards north south direction. So students, look at this video very carefully. Okay, thank you students.